Hey guys, welcome to our very first flipped lesson in Advanced Studies Algebra 2. The really nice thing about this video is you guys are going to be able to pause and stop and write down everything you need to. If I'm going too fast, if something didn't make sense, rewind it, rewatch it again. I'm going to ask you to pause the video several times during the video and try things on your own, and then I'll come back and put the answer up. So, first thing you need to know, we're looking at graphing quadratic functions. And today we're graphing in standard form. So this form you see on your screen, y equals ax squared plus bx plus c, is standard form. A cannot be 0. You have to have that x squared term there. And that graph is called a parabola. So we should be familiar with what a parabola looks like. If not, it's going to be this U shape. So we're going to look at just some basic parabolic graphs. So the first thing I want you to do is take a minute in your calculator and type these terms in. So you're going to hit y equals, and in the spot that says y1, you're going to type x squared. Hit graph. You'll see that picture that I just drew come up on your screen. Then I want you to go back, and in y2, put 2x squared, and in y3, put 3x squared. Take some time right now, pause the video, and write down what happens with 2x squared and 3x squared, and then write down what happens with 0.5x squared and 0.2x squared when you type those in. Okay, and you may have some different things written down. Hopefully you're back with me now and you have tried out all of these. But when you typed in 2x squared and 3x squared, that's what we call a vertical stretch. We're always referring to it in how it translates vertically. So it's a vertical stretch, but some of you might have said something like the graph got narrower or skinnier. And then the opposite probably was true with 0.5x squared and 0.2x squared, that the graph got wider. But that's a vertical shrink. All right, try these. So pause the video again if you haven't, and come back to me in just a second. Okay, so hopefully you have typed these in. You've left your y1 as x squared. So how it compares to the original x squared, this one reflected over the x axis. Shorthand to write that is r with an x in the subscript. And then the last one, this one moved up 1, and this one moved down 2. So hopefully you're noticing some patterns happening there. All right, steps to graphing a parabola in standard form. If you have y equals ax squared plus bx plus c, step 1, find the vertex. This equation right here is important. You need to know this. X equals the opposite of b over 2a. You're going to use that to find the vertex. So you're going to put the opposite of this b value over 2 times this a value, and that's going to tell you the x value of your vertex. Once you know x, you're going to substitute x in to your original equation, and you'll solve. Then step 2, plot 2 points on one side of the axis, and then use the axis of symmetry to find 2 more points. So notice, hopefully you noticed in your graphing calculator that it was symmetric on both sides. And then the last step is to label the axis of symmetry. So let's try to graph here. I have y equals negative x squared plus x plus 12. I'm going to write out, and you don't have to write these if you are comfortable with it, but a is negative 1, b is positive 1, and c is 12. So I know that x equals the opposite of b. So the opposite of b is negative 1 over 2 times a, negative 1. So then I end up with positive 1/2 when I simplify that. So if x is 1/2, I'm going to set up a table here. I'm going to put 1/2 in the middle. So if I plug 1/2 in for my x values, I should get 12.25 out. If you want to pause the video here and try this on your own, go for it. Then I want to go the same distance away on both sides so that I can use my axis of symmetry. So I'm going to pick 0 as another point because 0 is always a pretty easy point to pick. And I'm going to pick negative 1. So if I pick 0 and I plug that in, 0x squared plus 0, or 0 squared plus 0 plus 12 is just 12. So that means if I go the same distance away on the other side, I'm at a positive 1. 1/2 to 0, 1/2 to 1. So 1, if I plug it in, negative, and then 1 squared is 1, plus 1, those cancel each other out. I get 12. It should be the same based on our axis of symmetry. And if I plug negative 1 in, negative 1 squared is positive 1. The opposite, though, is negative, plus negative 1. So I have negative 1 plus negative 1 plus 12. So I get 10. And so then 2 should also be 10 if you plug that in. You can pick other points. You can pick as many points as you need, but you need at least 5 total points there. So if I label my graph, I notice I'm going above 10 here. So I'm going to go by 2's on my y-axis. And then I'm going to go by halves here, I think. So I'm going to go by 1, 2, 3, negative 1, negative 2. So then half, I'm up to 4, 6, 8, 10, 12.25. At 0, I'm up exactly 12. At 1, I'm up exactly 12. At 2, I'm up 10. And at negative 1, I'm up 10. And I'm going to connect. All right, finding a maximum and minimum values. So we have a positive and a negative, and we're going to go over the keystrokes together in class. But think about when you will have a maximum value and when you'll have a minimum value. So a positive parabola looks like this, where you have a positive a value, whereas a negative parabola looks like this. We have a negative a value. So on a positive parabola, we never have a highest point. We never have a maximum because those two arrows tell you that it's going on and on forever. But we have a minimum down here. And that minimum occurs at the vertex. For the negative, we have a maximum at the vertex. Okay, so I will see you all in class. We will go over max and min keystrokes, how to type it in your graphing calculator. If you have any questions, please come in and see me. I'll see you in class.